to help support you with our square root problems. And as we get into estimating, I want to make a quick video about examples. And as we start, I had some sunspots that are a little bit glaring today, so give you a really nice picture of these really nice sunny but still cold morning today. We're just going to go, and on this page, I would like you to pause, and if you need to, take a screenshot of this so you have some of this for your records. But knowing these perfect squares is going to be really, really valuable. I would say as long as you are pretty darn clear up to 13, that's going to be really solid, but these 14s and 15s are still really nice to know. I would see that most people, or most often, you're going to start to be counted on to have these numbers memorized. So this is, as we can get there with me during this year, but I know your high school teachers and your algebra teachers will be expecting that we can kind of start flying through these different exponents and radicals between the square root of 1 and the square root of 169. So one thing we'll keep practicing is to how we can get these quick and memorized, but if you have these as a screenshot, we can always refer to these quick square roots really nicely. There is an error, something that I'm not crazy about on this picture, and because of the answers that it kicks out. So I'm not crazy about what it gives you for an answer. The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. There's something else that I think it's missing. So we'll talk about that during class and see if you can pick up on that too. So to see, take a screenshot of these so we can have these start to become memorized. As we start getting into our estimation, so we're going to have you do square root of 12 or other numbers that aren't perfect squares and be able to estimate those without having to use a calculator. So this is just me a tool just to really understand where those estimating roots are and how we can kind of manipulate them and figure out what they need and how to solve if we ever don't have a calculator or if we don't have the time to, but kind of wrapping our head around that number sense. So we have the square root of 12. Really what I'm looking for first is I want to know the perfect squares that are below and above 12. So I'm going to make two little lines here to start, and then what I'm going to put there are the perfect squares that are directly below and above the square root of 12. So I know that there's a perfect square at 9, and then that's the one on below 12, or square root of 12, and then I know there's a perfect square of 16, and that's the closest perfect square above. Look, as I solve these two square roots, I know that my answer is 3 for square root of 9 and 4 for 16. This original square root should fall between two exact perfect squares. So we shouldn't see a gap that would be down here between 3 and 5 or 3 and 6. These two numbers should be directly sequential to each other, so directly right next to each other on a number line. So 3 and 4. So our goal right now is to find the two perfect squares that are directly above 12, square root of 16, and directly below 12, 9. So now that I know that the square root of 9 is 3 and the square root of 16 is 4, I can start to help myself estimate. So the next step you're going to do is, once you have those solved, is to draw a number line in between them. And then once you have your number line, you're going to see kind of how close the square root of 12 is to the square root of 9. Really, we're 3 square roots away, because 9 plus 3 gives us 12. And in here we have the square root of 12 to the square root of 16, and so that is 4 square roots away. So if you know the distance between 12 and 9, you can kind of start to help yourself figure out exactly where it's going to be on this number line. So looking on this number line, I'm going to know that 3.5 is right about here, and then that makes this about 3.25, because I'm looking at that as halfway, and then that makes this 3.75. And then I can start to fill in some different ideas. If I know that then this could be about 3.1, 3.2, 3.3, 3.4. Then we have 3.5 here, so now I have 3.6, 3.7, wrapping around 3.75 to 3.8 and 3.9. So if I looked at these two numbers right here and I saw that they were exactly the same, I know my answer would be exactly 3.5, because it's falling exactly in the middle, meaning it's the same distance away from my two perfect squares. So since 3.5 is the same distance from 3 as it is 4, that would mean it's the exact same distance from the square root of 9 and the square root of 16. However, that's not the case here, because we don't have equal distances between our square roots. I have distances of 3 from 9, and square root of 12 is 4 square roots away from 16. So I know that my answer is not going to be 3.5. I know it's actually going to be a little bit closer to the square root of 9, because we're only 3 numbers away from the square root of 9, where we're 4 numbers away from the square root of 16. So if we're 3 numbers away from 9, I know that my answer is going to be somewhere lower than 3.5, but it's still pretty darn close, because these numbers are so close to each other. So when I'm estimating, again, I'm just kind of roughing around, I'm thinking your answer is going to be 3.4. As I plug that into my calculator and actually check out what the exact square root of 12 is, so let's see, come on, calculator, let's get to work. I punch in the square root of 12, and I come up with an answer of, so calculator answer said it was 3.46410 because we're going to go on for quite some time. I'm not seeing a ton of repetition happening here. So if I look at my estimate, 3.4, to what the calculator gave me, 3.46, I can see that I'm really close. And in the case of being off by a couple hundredths, that's not too bad for estimating. So we're going to do one more together as we kind of estimate these roots, and then so you can use these to help yourself. All right, again, taking a look at this step, let's get ourselves set up in terms of what we know. First step is to find out the perfect squares above and below. So if I'm trying to solve for the square root of 71, I need to figure out what is the perfect square that's directly below 71 and the perfect square that's directly above 71. So I know for sure that we have a perfect square at 64, and that is lower than 71. So that represents 8. And so now if I want to check out 9, I know that is the square root of 81. So now I know that 71 falls in between those two perfect squares, between 8 and between 9, or the square root of 64 and the square root of 81. So now look at distances. 71 is exactly 7 numbers away from the square root of 64, and then the square root of 71 is 10 numbers away from the square root of 81. So now if I look at this number line in between 8 and 9, I know I'm going to favor the side of 8 because we're only 7 away from the square root of 64, where we're 10 away from the square root of 81. So if this is 8.5 right here, I'm going to go closer to about maybe 8.25, 8.3, somewhere right in here. So let's jump ahead on our calculator. If my estimation is 8.3 as I plug in the square root of 71, the actual answer gives me 8.426. So my estimation was a little bit on the low side, so I could have even bumped up because these numbers are so close to each other, between 7 and 10. And as you see these square roots get bigger and bigger, the closer those numbers are, the closer they are can actually kind of become closer to center. So if I start to get up to the square root of 225 or the square root of 169, I might start to see some differences that are not as close as 7 to 10, so that would give me the hint that I can maybe go to about 8.4. This is just one final example to help us through. So here we have the square root of 24, and let's see how we can estimate that. Again, looking for higher and lower perfect squares directly above and below. I know that we have a perfect square at 25, and that is very close to 24. That means if I know that number is 5, then I'm looking for this perfect square that gives me 4, which is the square root of 16. So now I'm looking for my distances in between 24 and 25, and 24 and 16. These distances are really helpful because I only have a distance of 1 between 24 and 25, but then a distance of 8 between 16 and 24. So when I make my number line between 4 and 5, I know that I'm going to be way closer to 5. So if here's 4.5, and if that would be the case if these numbers were exactly the same, but since they're not, and since I'm way closer to 25, the square root of 25, I know that my number is going to be kind of way somewhere on this half of the number line, really close to 5. So I'm going to estimate and say that I am roughly going to be at about 4.9. And if we double check on a calculator to see how we are doing, the square root of 24 gives us 4.89. Oops, that is a rough looking 8. 4.8989. So I was super close, and a really strong estimate when I made it at 4.9 when the calculator gave me that number right up there. So we're going to use this method to kind of help us estimate square roots. Again, use this video to help you kind of bounce around and see some different examples and ideas of it, and allow you to see these how square roots can be estimated. Best of luck.